we are recording. This is Math 60, and this is 7.2 part 2, and we are simplifying expressions with radicals. Specifically, we're going to be playing with a lot of radicals, a lot of exponents that are in fractional form. So let's go ahead and get started with number 4, and let me write it bigger so it's easier to see. 2 to the 5/3. There are two ways to approach this problem. One way is to look at it with the fractions, the exponents as a fraction, and the other way is to look at it as a radical. So let's go ahead and start the fraction. I know, I hear everyone going, oh no, not fractions. It's okay, we've got our favorite carnivore and or omnivores with us, and they will help. You can be strong. Woohoo, we can do this. So first thing we want to do is maybe take a look at 5/3. 5/3 can be broken down into 3/3 plus 2/3, right? Because 5 breaks down into 3 plus 2. And that's 1 plus 2/3. So what does that represent? Well, so we can look at it as 2 to the 1 plus 2/3, which means this is 2 to the first times 2 to the 2/3. We can split them up. Now 2 to the first is just 2, and 2 to the 2/3 is a radical. So we can write it as a radical, I should say. So that's the cube root of 2 squared, or we can write it as 2 times the cube root of 4. Woohoo! Okay, that's one way to look at it. Another way to look at it is to go ahead and write it out as the radical. So this is the cube root of 2 to the 5th. And so that means it's the cube root of 2 times 2 times 2 times 2 times 2. Well, we know from bear math, do I have my bear here? My bear is right here. If we've got a cube root, we want to let these 3 2's go running. And then the bear comes through, yum, 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 yum. And those 3 2's go running and come out and only 1 survives. And then these 2 2's don't go anywhere. So we end up with 1 2 on the outside, and then the cube root of 2 times 2. The 2 2's that couldn't run because they needed 3 to go running. And so that's equal to 2 times the cube root of 4. Woohoo! So you can approach it either way. You don't have to go with one way or the other. You can either look at the fractional exponents or you can play with the radicals, whichever way is more comfortable. Honestly, it will go better in life in general. Let me draw a straight line here, so hopefully that keeps these two separated a little bit. In math, certainly, if you're able to approach it from both sorts of perspectives, math will go more easily. And I do believe that more math means a better life. Let's just be honest, right? Okay, next up, the 12th root of a cubed. Now, this is an example of a problem that can be dealt with as a radical, but I think a lot of people have an easier time of seeing what the heck is going on if we write it out with fractional exponents. So I'm going to write this out as a, and then the exponent of a inside goes on top. The index of the radical goes down below. So we've got a to the 3/12. Well, 3/12 can be reduced, right? We reduce the fraction. And so we end up with a to the 1/4. Do you see how 3/12 reduces to 1/4? Which can then be written as the 4th root of a. Now, with these answers, depending on what the particular problem asks for, you may want to give the answer as a to the 1/4. You may want to give the answer as the 4th root of a. So it's just going to depend on what the formatting of the problem is. So just pay really close attention to the instructions. Okay, next up. Ooh, this one's very exciting. Look at all of this. It's a real juicy problem. Lots of stuff going on. This is the cube root of AB, and the whole thing is raised to the 15th power. Now again, we could work with this using the radical, but I'm going to recommend that a lot of people will be able to visualize it better if we consider that this is AB to the 1/3 and then to the 15th power. The cube root is the 1/3. The whole thing is to the 15th power. And so remember that the rule of exponents is that if you've got an exponent inside and an exponent outside, you multiply. And if we multiply that, let me try getting in there. I've got 3 goes into 3 once, it goes into 15 5 times, and then we end up with AB to the 5th over 1. So in other words, it's AB to the 5th. And it may be written, and again, this is going to depend on what the instructions say. It could be that they want you to write it out as a to the 5th, b to the 5th, or it may be that it is acceptable to write AB, the whole product to the 5th power. That's going to depend on the setting again. So now, in both 5 and 6, for 5 and 6, I had said you could work with the radicals, but I think the fractions will be easier. Let's look at what that means. So here, in number 5, you can see the 12 on the outside, and you can see the 3 on the inside. Remember that the 3 is in the numerator, and the 12 is the denominator. But it is just as easy to kind of reduce right here. Can you see how you could reduce the 12 into 3 and end up with a to the 1st power inside and the 4th power, the 4th root on the outside? See how we could do that? You can kind of cancel. Now, what are the downsides? Well, the downsides are you have to remember that when you're reducing like this only works if you've got a single thing inside. One, not just one expression, but one factor. This only works, and this one factor is to this exponent. So you can't have anything else. Like there can't be a +1 inside. That would be right out. But if you do have a single variable raised to a power, and then you've got an index here, you can just know that the 3 and the 12 will cancel, and it'll leave 4, right? 3 into 3 goes once, 3 into 12 goes 4. You can reduce straight through the radical like that. Let's look at how it would work here. Now in this case, 15 is on the outside, but again, we still know that this cube root is a 1/3. So we think I cancel the 3 and the 15, and this is 2 different variables, but they're in the same boat. They're together, multiplied together. So they're going through the same stuff, so we can get away with it. Again, if there were a +1, if this were AB and then a C to the 28th, you may want to do it more carefully. So this is a very simple radicand. Then I can see the 3 and the 15. See, they can cancel to a 5 on the outside. Can you kind of imagine that? So you are allowed to do math like that if you're very careful. Now, there are a lot of pitfalls that are possible. So again, that's why I said, hey, you know, let's work with the fractions, because they won't let you down, and that way you won't miss anything that's kind of snarly. But if you feel comfortable, it is a shortcut. Okay, one more problem. Yay, we're going to do one more problem, then we're going to be done. Yay, we will know everything in the universe. Okay, first off, let me rewrite this one, because boy, is it tiny. X to the -1/3, y to the 2/5, so that's multiplied together, and the whole thing is raised to the 1/4. So in other words, we're taking the 4th root of this. Now, what I would recommend is the easiest way to deal with it, and there are a couple ways to deal with it, but what I would recommend is that you would go ahead and use the rule that says I'm going to multiply those exponents. This is a rule of exponents. It still holds even when we've got weird exponents. Y to the 2/5. So each one gets its own 1/4. So I've Oprah'd the 1/4. And then what you do is, since there's an exponent inside and an exponent outside, we're going to multiply. Just like we did up there. This gets multiplied. So we get x to the negative 1/3 times 1/4. And this is y to the 2/5 times 1/4. So this becomes x to the negative 1 over 12. And this becomes y to the 2 over 20. And now an interesting thing happens here, because this fraction, even though it's an exponent, you can reduce it. And you could reduce it right there if you saw it. Or we're going to reduce it right here. And we end up with x to the negative 1/12, y to the 1/10. Now, that might be the answer that the book is looking for. Or it could be that it wants you to go to one more step, which is to put the x in the denominator. So this is going to be, let's see if I've got room, y to the 1/10 all over x to the 1/12, because that was a negative exponent. Or it could be that what the book is looking for is the radical representation. So y to the 1/10 is the 10th root of y. X to the 1/12 is the 12th root of x. So we've got 3 different ways to express the same expression, and it's really going to depend on the instructions in the problem, which one you go with. Okay, woohoo, we did it, look at us, yay! Well, you guys made it to the end of another section. And that's it. So I will see you in 7.3. And until then, get some vitamin D, get some exercise, eat your vegetables, drink lots of water, and math on.